Welcome to this session of Power Platform Well-Architected Framework. My name is Ali Yousefi. I'm a Principal Cloud Solution Architect at Microsoft. In this session, we're going to cover refactoring and code quality. On the agenda, we're going to talk about why code quality is important. We're going to look at refactoring specifically, refactoring how to approach it, and then an example at scale. Why is code quality important? So code in itself is the logic that makes your application run, right? It interacts with your data. It's the layer between what your user interacts with and the data that they interact with. So that could be anything from the presentation layer, the business layer, the data layer, whatever it can be. But all of that encompasses code, and all of the code you have needs to be of good quality, right? So continuous improvement, as we write our code, we should always be mindful of how good our code really is, right? Because code quality will impact everything from your application's performance. If your code is not of quality nature, it can impact your users, how they interact with the platform, how long it takes for operations to happen, how long business transactions take, which can negatively impact your entire organization's bottom line. Code quality reduces errors. As you start building more and more functionality into your application, errors will come up. Code quality is something we look at to help reduce errors. By writing quality code, by continuously taking time to review and improve your code, you can reduce errors. It'll also help reduce your maintenance cost, right? Each project has its own budget with cost and so on. This will help reduce the maintenance by looking at things that make your code a little bit more readable, reusable, modular. How could we build code that we know will continue to adapt to changes, right? So that's called improving your code and code quality. Finally, code quality will impact your team's ability to quickly react. So we talked about readability, but maintainability. So if there's change to a platform that you're working with, an application, whatever it is, if there's something that does change, you need to be able to quickly react. And code quality will be paramount to how quick your team can make changes to the code to ensure that your business operations stay up running. All right, so now that we've talked through a bit about code quality, why it's important, let's identify some candidates for code quality, right? So rehearsing on critical business operations. So testing is something we need to do regularly. It helps us provide quality checks and gates. It has guarantees allowing us to avoid costly changes, right? So test early, test often, unit test, integration test, regression test, UAT testing, whatever it may be. Continue testing, have that automated, have that manual, have it however, but always have testing going while you're building code on new code as well as existing code. Collecting telemetry, so ensure that you're writing useful and meaningful instrumentation within code. It helps you detect defects as soon as possible. Nowadays, platforms have automated alerting systems that can alert teams immediately when there's defects happening, when there's performance degradations, whatever it may be. But what is foundational to all of that is have a robust telemetry within. That'll help your support teams also be able to quickly troubleshoot and remediate any issues. Review any business logic that's dispersed across multiple objects or systems. We want to always be looking how we can reduce our technical debt. We see code sprawl. It's a major thing that happens as teams onboard new team members, new projects, new business units, whatever it may be. There's always going to be some code that's brought in that could be potentially refactored or even unneeded, right? Unneeded code can lead to potential bugs. So always try to stay lean, and just remember, it's a good acronym. It's something that I picked up from Martin Fowler, which is the you ain't gonna need it. So review your code, build it towards a way that is meaningful. Don't build for something that you don't need. If you don't need it, then you're just building code that you're going to have to maintain and test, and it's just not going to be beneficial, right? So make code that's adaptable, but don't necessarily write code for the sake of writing it, right? Always be looking for opportunities to reduce your code footprint. So a really great way to reduce your code footprint is by refactoring. So refactoring is nothing new. We've seen it. We've probably done it. And there's plenty of tools to help us do it. So we're going to look at refactoring and approach to refactoring within Power Platform and Dataverse, and we'll go through some specific examples. Okay, how to approach refactoring. Most likely when you're building out your implementation, you're delivering, you have deadlines, you have cycles you go through. Refactoring may or may not be part of that. I've seen it a lot where it's not, quite frankly, and it seems to creep up after post implementation. We tend to put that sort of on the back burner. Well, it's important to even have this code refactoring efforts within your implementation plan as well. So as you're planning each cycle, add some code quality efforts into each development cycle. If that's running automated tooling to scrub your code and look for callouts, right? There's plenty of tools out there that can do that kind of stuff, and add that to your backlog of things that need to happen. But whatever it is, add time into that cycle for code quality efforts. It will ultimately ensure a more healthy implementation. When you do identify for non-quality attributes, so there's tools that will help potential refactoring candidates. Also look for your entire code base for anything that could be considered not quality. So look for code that doesn't follow, say, a naming convention that you've agreed on, or isn't really that maintainable. We'll cover what maintainability is here in a bit. But review your code base regularly for anything that could be considered non-quality. And finally, test. Always test. Write clear tests that ensure changes to code don't break existing functionality, because as we look to refactor, we will be modifying code. It's going to be beneficial and it's optimal for our organization to go through this, but we always have to ensure our code is not changing. So be sure to implement testing to regress, to make sure nothing is changed when you do make this change here. All right, so once we've agreed to refactor, we've planned it, we've identified some good candidates, how do we start, right? So I'd say that start small. If this is something that's going to be new to your project, maybe agree with all the developers and all the different teams on naming conventions, right? That's something we can agree on that helps. It's going to help with readability, for instance. So making it clear when we look at code, we know how things are named so that it's just more concise to all of us. Review bloated or unreadable files, classes, and functions. So this is something I see a lot within plugins, definitely see it within Power Apps low code, where you'll just have just a long line of just code that is just sort of like a waterfall. It just goes and you have to read through it like a book almost. Refactoring helps by taking a lot of functionality, putting it into subroutines. They provide clear naming on what it is. So look for big files, right, that seem to be where a lot of business logic just gets put into it, and see what you could do to help modularize that, sort of extract that out. Think of separation of concern as something that would be something we would want to achieve there. Finally, duplicate code. That's always going to be a problem. That's just going to be costly to your organization, right? So that's where reusability is something we'll want to focus on. Reusability we'll cover up here in a minute or so, but look for duplicate code. Look for naming conventions that just don't mesh, don't seem to work together, and review big files, right? You can look at your code base, and most repositories now show you the size of the file. There's the number of lines of code you can see, or where users are checking in changes to code, and maybe there's a single file, for instance, that is extremely big. So in an example we'll have later, we're going to look at how we can take a file that's been up to 5,000 lines of code and get it down to almost under 100 lines, from 5,000 to under 100, using refactoring. All right, so one good quality attribute of software is maintainability. So what is that? That's how adaptable is your code to change. So I did an example here. We're going to go through it after the slide, but we're going to review code that was generated from ChatGPT that's going to work with sales orders. We're going to talk through how adaptable is your code to change. Okay, for this example, we are going to look at some generated code from an AI software, in this case ChatGPT. So for this one, I requested ChatGPT to create a Dynamics plugin that will go get products for an order, right? So this is actually the code. I've taken it from ChatGPT, just put it into into a class here. It's actually nice that it looks like it may compile just fine. But I thought it'd be interesting to look at this from a maintainability standpoint. So we'll look at this one as well as another one I've created. So looking here first, just looking at the code, I could see maintainability. Some concerns here, maybe this fetch statement, right? So as we talk about changes to code, right? How to make this more maintainable. We know that changes could happen to the data model, could happen to business logic. So an example here, I see quantity. Quantity is a decimal. So looking at this, there might be some area of improvement where we could maybe change this decimal here to something that could be a little bit more flexible, just in case we do decide to change quantity to something else. Maybe it's an integer, maybe something here. Another great example for maintainability, if you see fetch XML just generated within code like this, like inline, there's opportunities here to sort of refactor this fetch XML, right? So you could actually take this and extract this to maybe a different function to help, or potentially even make some parameters to pass into this, like maybe adding specific attributes right here. Another thing for maintainability would be this piece. I see this for each. It's going and getting the opportunity products, and it's looping through each opportunity product, getting the ID and the quantity. This here, this is where probably the vast majority of the business logic will happen. So this is where we want to be keen on where we focus our maintainability efforts, because this is where most likely your bloat will happen, and your changes will happen. So really focus on the areas within the responses from, in this case, the fetch XML, so that you could focus on making this a bit more maintainable. If it's looking at how to extract, how we're grabbing attributes from the classes, how we're working with typing, conversions, things like that. So be mindful of all of that. Overall, it looks pretty good. It's a very basic example, so nothing here really stands out. I went ahead and made another call here for ChatGPT to make me one that does an external web service call. So I thought this one actually had a little bit more sort of stuff we could look at. So in this case here, it's created a subroutine called make web service call. Inside of it, we see a hard-coded string. So that's definitely going to be an issue for maintainability. So in this case, you'll want to extract this, put this into things like the configuration of the plugin, for instance, right? Take this, put it somewhere that can be adjusted without having to recompile the code. As it stands right now, anytime this API changes, like for instance, if you now have to say get ordered, I now have to recompile the plugin. I have to go re-register all that stuff. If I were to have this extracted out into maybe the configuration or into a separate entity, something like that, gives me a little bit more flexibility. So that's definitely something we want to look at. Readability. How understandable is your code to other developers, to the project as a whole? So again, we're going to look at ChatGPT code and see how readable it is once it's been generated. Okay, so readability. How easy is it for another developer, for instance, to take your code and be able to understand it, be able to if there was a bug, be able to quickly find it and address it. So again, we're going to look at ChatGPT generated code. This one's for retrieving order products. Overall, I like this one. I think it's actually pretty readable. Right, the class makes a lot of sense to me. Retrieve order products. It tells me that's what it's doing. It's added comments here, which I think is highly beneficial to another developer who may be picking up your code. Nothing, again, this one's very basic, so everything looks pretty good here. Again, this will be the bulk of your business logic, so this is where you really need to be readable. But what I would say is make sure you add comments. Make sure your naming conventions make sense. So if you're going to go with camel case, or if you're going to go with some other type of naming convention, keep it consistent across the board. Think about how you're building your fetches and how they could be readable. Maybe add something here to the fetch to say, hey, this is based on this. Maybe even add work item numbers, for instance, inside of your code could be something that could be beneficial. Another thing here, exceptions, definitely want to make sure that the exception message is readable. It needs to be something that provides context to a developer who's troubleshooting, but then also maybe provide useful information to the end user who may experience the error from the business logic. From the web service call, again, same thing. I like the refactoring they've done here already. Calling it make web service call, making the web service call here. Again, a lot of comments, very good, very good. And then response body. So overall, pretty good job by ChatGPT on readability. Some other examples I have. Here's one that shows using the query expression. This one has basically almost no comments whatsoever. You can see it's using some logger, iLogger. It's doing some retrieve multiples, but not really telling me anything. Plugin failed. This is not a good practice. That simply just says the plugin, but didn't tell me what really happened. I'd have to try to dig into the stack trace to find out more. So this is an example of poorly readable, understandable code. Looking at some other ones we have, see update recursive. Again, this one's it's hitting some attributes, setting date, time. We're not sure what's going on here. Be nice to say, set, let's just set expected and response time to today, plus 2 hours. So that at least helps a developer understand what this is supposed to be doing, right? So make sure you add comments, make sure you use, exception messages that are friendly but useful and can provide context to a developer. Reusability. How costly is your code to your project budget? This is probably one of the biggest benefits you can get out of refactoring. The maintainability, the readability, but definitely the reusability. How can I reuse code, reduce the code footprint that I have, make something a little more flexible for other team members to be able to use. This will help as you grow your project, as you start building out new code. Always think about what can I do to make this code more reusable. So in this next example, we're going to take the code that's generated from ChatGPT and see what we can do to make it more reusable. Okay, reusability. How costly is your code to the organization? So looking at this one, back to the ChatGPT example, we have the sales order, the fetch. We know for sure that this here definitely is not going to be reusable. I don't see anything here that I would necessarily be able to reuse. This is not refactored at all. If I was another, say, class and wanted to reuse this particular fetch XML, I would have to go regenerate it and call it. Again, it's the same with the business logic. So none of this has been refactored at all. So this is a high candidate for reusability. There's basic stuff you could probably do. I could simply highlight. This is Visual Studio. I can highlight. You can do quick actions in refactoring. Some nice tools here. You can extract a method. Call it whatever you want to do. Say process, order products or something. So now you have this quickly created this, made it reusable. So if I wanted to try to reuse this here in another class, I could. Now, some examples we want to look at. This is not really a great reusable function because of the fact the person's private. So we would not be able to really do much with that. I'm not a big fan of it throwing static in there, especially when we start talking about plugins where we're not quite sure, okay, if the class is going to be is going to create a new instance each time it's called. If it's going to reuse it, if so, then you're not going to have a stateless sort of setup here. So static can be widely impactful if you're building towards a stateless approach, because in that you're going to potentially have state still there with it. I've seen that happen. It's definitely an issue. So here we have process order products. So I've flipped that around from private static to internal. Now, if I were to go here and say, oh man, I need to work with this here. So we have a public class, right? So, I don't know, let's just say order products. This Visual Studio is very helpful here. And now you see you actually have this order products if you needed it. You'd have to obviously pass in your entities, your query, like this one's doing here, but you now have that same logic available. So say I wanted to do, have my own query for this one, like maybe it made a web service call out to something. They go get data, is order products, pass this in, so on, right? Kind of fix this up a little bit here. So you have some opportunities to reuse this now, this business logic. So there's an example. On the ChatGPT for the web service, they did make this web service call, made it private and void. This is something we definitely would want to extract out into maybe like a helper class or its specific class that can be reused, because web services, this is something that definitely will be used quite a bit, and you don't want to have many different classes, creating its own web service calls. Because if you have to change something, for instance, one of the things that happened in the past several years was moving to TLS, 1.x. And so adding those headers or doing things like adding headers to keep alive set to false or whatever it may be. All of that, if you had that, say you had 100 web service calls going, different code doing web service calls in 100 different places, you need to make a change. Well, now you got to do that 100. That's very costly to your organization. So having something that's reusable here to do something very generic like a web service call could be beneficial to your organization. Final thought on this one, if we would extract this out, obviously, which I won't do on this one, but I would probably also return one of two things: either the response itself, which might be beneficial, right? So I can do something like this, and then when you're here, process, like it said, return response. Or, even the response body, whatever you want. But void, traditionally, not on a web service call. You want to like look at it and take action on it. Other than that, everything looks pretty good here. So looking at some final ones like this one here, retrieve multiples many times. This definitely could be extracted out. Again, Visual Studio has a nice tool. You can right click, hit refactor, extract methods. Something generic, and you can build off of that, right? So you have this here. This is not good, so I would change this to do something. Make that a little easier, right? That the name. Go here. This is whatever this is, so account. And then instead of doing this piece here, I could scrap that all together. Say contact. Now it's doing a retrieve call, so again, this void's not really helpful for us. So we want to do entity collection. And we'll separate that is here, and return. Actually, we'll just return this. And now you've got it. So now you've got your collection. You could say, I don't know, account results. So on. See, then you'd have it for each one. And so if you ever needed to make changes to how you're making your calls to Dataverse, for instance, you could quickly just change it here, and then you have this reusable. So that's an example of refactoring and how it can make your code more reusable. Okay, a couple more advanced talks as we go through refactoring. So in this one, we're going to cover low cohesion. This is an example from a framework provided by Microsoft called Easy Repro. This is a UI testing framework. So in this example, we have a web client file here. This is the class that I was mentioning that has over 5,000 lines of code. You can see it has a region called Power App. It's got a region called Form Context Type. It's got many different regions here. What happened with this particular class is that every single focus area of the code, from how to work with entity forms, how to work with grids or lookups or dashboards, whatever it is inside of the UI, all of it got stuffed into this web client file. So this was an example of very, very low cohesion. You open up the web client file and it's doing everything. It's opening up apps and opening up forms, saving forms and changing views and working with subgrids, all this stuff here. So this is a good example of low cohesion. Let's see what we can do to get a little bit better cohesion. Okay, so here's an example of some better cohesion. I took the code that was specific to entity, so that's working with entity forms, and move that into an element file entity here. Before I go into this, I want to back up and just talk through what cohesion is, right? So cohesion is, example would be to have code that makes sense to be together, right? So as we look at the web client example, it was touching entity, grid, so on. That's low cohesion, meaning that it doesn't really, if I open that file, I can't really determine what's going on, except that I know that it's going to be interacting with lots of different things. Cohesiveness will help with maintainability and potentially sort of all of it, readability and reusability, by bringing things that are like-minded or like specifically like what they do together, right? Separating sort of that concern of what they are, bringing them in helps with quality, right? So we always hear about high cohesion, loose coupling. This is an example we're going through here. So in this case, we have entity. We know this entity is working with forms, everything in the forms, from changing tabs, from working with controls, whatever it would be. So we're adding things that make sense all within the entity object. So we have a DTO, which references different things on the entity form. We also have objects that entity relies on, subgrid, related grid, and so on. We have the constructor here that's passing in the web client as its dependency. So I like this, passing in whatever dependency we have when you have to create the instance of entity here. So this was a very good example of having to refactor without making breaking changes. So this code base is used by hundreds, thousands of organizations around the world to test their Dynamics 365 and Dataverse instances, so we can't introduce any breaking changes. So in this example, subgrid and related grid, they're publicly exposed here, but what we've done is we've taken that logic out of the web client and then moved it into the subgrid and related grid. So if I need to make a change to subgrid, how it works, if I need to say a subgrid changes to be editable, right? I can make all that change and have all that code encompassed in the subgrid object. So I don't have to go hunt around to go to the web client here or go somewhere else here. So in this case, entity needs subgrid as part of it, as a property of it. But any code that works with subgrid will be inside of subgrid. Same with related grid. So here's an example of making it a little bit more cohesive. Let's take a look at refactoring using an example at scale using the Easy Repro project. Okay, welcome to this demo of refactoring. In this example here, what I'm going to show is something that's already been refactored. I'm about to actually check this in, push this out to a public repo, and then I'm going to go through refactoring a simple example, and then I'll go through a little bit more complex example. So let's go into the first piece of this, which is showing a commit that I'm about to push. So in this case here, we're showing a change we've made to this web client page. So this web client had a region in it called Performance Center. It had multiple regions you could see, but when I compare, I can see the change in it from what's been there to what I've removed. So where did that go? That actually got removed from this web client page to a specific class called telemetry, which will now host the Performance Center. Inside of there, I can see now with telemetry, I've now moved in the enable Performance Center code into the telemetry class. Why did I do that? The reason I did that is that the Performance Center operations, the Performance Center properties, everything that's related to this telemetry gathering piece of the code sort of resides within needs to reside within that own element, right? It makes sense to keep it within to help with cohesion, to help keep everything that's responsible for working with the Performance Center or telemetry within this application, this code together. It makes it readable, makes it more usable and more maintainable. So we've actually moved things out of this web client into a specific element class. We also had a reference to it through this particular code uses XPath. And so what we did is we took this class, moved it into telemetry. We can see we had that stage. We also had another staged change here, which used the actual XPath. That has all been moved into telemetry. So instead of having a class that says container with performance widget, and then having a dictionary with the XPath, we've simplified that by going to telemetry and adding that class here as a static class, performance widget reference, that now has container page with the XPath. So that's an example of one. We're going to go ahead and check this in. Refactor telemetry, we'll commit, and we will push that out. So that's a push that we're pushing out to this branch here, features.net core. So now we're going to actually go start with some changes. So we'll go and close out this here. Go back to web client. Web client is the file that we, originally started with over, I would say, close to 5,000 lines of code. Since I've been refactoring this, I've got this down to about 1392. You can see we're going to go ahead and go through an example of a simple refactor, in this case, the Power App region. So if I expand the Power App region, I see a class member in Power Apps. I see several functions. Locate the Power App, Power App send command, Power App select, and Power App set property. Looking at the code base, I see on the api.uci project, we have an elements folder with a Power App. Let's go open that. So what do I see in here? I have a constructor passing in web client, which is the actual file we're using here. So right now, this thing is actually passing in web client and saying things like send command, select, set property, and it's simply going back into web client. So you will declare this Power App object, pass in the dependency, and then just go right back into web client. To me, probably could use a little bit more refactoring to make it a little bit easier. It doesn't make as much sense to me to I like this piece, but I don't see why we necessarily need to go back into web client. So what we're going to first do is go ahead, take this region, and just cut it. And we should see some issues with this now. Let's see. Yep, there we go. And we're going to paste that in. And I'm going to put that here. You're going to continue to see these. Don't get worried about this. This happens. In fact, you can even check in code at times with that is like this, but this is part of refactoring. You're going to see some errors happen, and you're going to go through and clean this up. So I've moved that code into here by simply going in and saying, you know what, I'm going to change it to say this. So what did I just do? I said, instead of pointing towards web client, I'm now going to point towards this, which is Power App. Power App actually has now an internal method called locate Power App. Has one called Power App send command, Power App select, you can see it highlighted, Power App set property, you can see it highlighted. You're seeing we still have some errors, and I'll fix that out. A couple things I would do here, I'm going to change these to private. Why am I doing that? I want to do that so that this is an internal command specific to Power App. I want only things that will publicly reference Power App to only use these public versions of it. We can't when we're refactoring, we have to keep in mind that we have existing users using this code. So I can't change the public methods of this code. So unfortunately, these will have to stay as is for now. The reason for that is you'll see if I look at the error messages here, if I were to change this to say send command 1, I should see some error messages pop up from some tests that I have. So the things that use it, the things that depend on it. So in this case, if there's a Power App test, which doesn't look like there is, but if somebody's using that, if somebody's using send command and I push this out and they got the latest version of this code, all of their functionality that was using some command would be broken. So we have to keep this as is for now. So I'm going to go ahead and pause speaking and just work through refactoring this. So actually first, what I'm going to do is say I know execute is part of my inherited web client. So I'm going to go ahead and change this here, like so. I know get options is also within client. So if I hit F12, I see I go into this. Easy, right? Well, one of the fun parts too is we're all now going to actually take this piece out of it. So if you see this app reference power app control, if I go to the declaration of this, I see that there's a static class power app that has model form container and control in app element. Again, we want to keep things related to power app together. So we're going to cut this here, take this to power app, and I'm going to put this in its own region. I'm going to call it DTO. I'm going to do this, called reference, because we can't call power app inside power app like so. And I'm going to go find the reference to power app, which is here. I'm going to actually comment this out. This helps me understand what maybe referencing this directly. So I'll copy this here. And that's model form container, and we will replace. Now we've created a class that has model form and control. So now we have a bunch of errors here. We're simply going to fix this by taking off app elements.xpath after. Make this a lot cleaner. Remember, this is a static class, so we can now simply do that. Take out this bracket. So you'll see we'll have a few more errors we need to fix. Bracket. Right, that looks like that's done. Some things we'd probably want to do as well is look at some of these XPaths here. So this find element iframe, that's something we'll want to continue to refactor. So when I see these hard-coded XPath strings, I want to take that and actually put this in the class. So whatever this is referencing this class, some published iframe, locate the power app. This probably needs to be, again, something that's referenced in here. So maybe published app iframe would be a good name for it. And go take this. Oops. Publish that. So now we've done that. So by simply doing a little bit of change, we've now refactored this code to now have everything contained within Power App. We'll go ahead and build. Everything has succeeded. We have now refactored our app event and push. And that's it for this example. Thank you. Okay, for this recording, I thought I'd just go ahead and show you commit for more complex refactoring. So this is the refactor login I just did. So in this case, we had a very significant amount of code that was tied within the web client, quite a bit of code actually. And we moved that over to the element like we showed before into online login. Went ahead and added all the XPath here. And then we also moved step out of the element reference, right? So this is all the XPath you saw. It's all now contained within online login. The biggest change here we need to be aware of is, again, we can't introduce a breaking change when we do our refactoring, right? So our refactoring needs to improve our code, right? That should be the goal of it. Improve the code, reduce any sort of blockers for maintainability, increase usability. We want our code to have quality attributes. So in this case, what we're doing is looking at continuing to have the same roughly the same signature of the public function that the user base will use, in this case login. What we're doing now is we're examining this, right? So we know it's public, we know it's called login, and it takes a parameter called org URL that is a URI. So what we've done is we've actually said, okay, since this is void, we know that nobody's expecting anything back from it. So an improvement that can be done here is to actually return back the result of the login as well. So actually return something. So as a user would use this piece of code, traditionally they would just say login. As you can see here, just use, where is it at? Let's see. There's probably a good login one somewhere. Right here. This file was deleted. Let's show it. So right here, online login.login. So they would use something like pass in a URL, pass in a username, and a password to go log into this app. So in this case, they are going to, where we go? We want to go right here. Yep. So they pass in a URL, a username, a password, and then if they have MFA, if not, it's null. So this one would work just fine for what they were doing. So in this case here, initially it was a void. Now we're just going to pass back the result of the login, right? So nothing would change. So when they ran this here, there was no expecting something, but now they can actually do a check. So this will improve testing as well for this particular code here. So we've now returned that, but we have not changed the signature, so we did not introduce a breaking change. What we had to do this time is change a line of code from this login to web login to do all this kind of work here. So this one had significant amount of change, as you can see. But if you want to review any of the refactoring examples I've had, you can simply go to this repo here. This one's called Easy Repo. This is a Microsoft one, so it's used by hundreds of customers, thousands of customers, quite frankly. And it has different branches. Right now, the one I'm checking into is called features.net core. You can go here and go look at the different commits. And depending on when you're seeing this, you might see different commits, but look for these ones called refactored, and you can see different examples that have been done from lookups, grids, so on. So that's an example of that. I wanted to leave you finally with some more refactoring as we look ahead. So web client now has been refactored from, we go look at another branch that has not been refactored. Let's take the default branch. Web client currently on this branch has $5,963, almost 6,000 lines of code. We've refactored that down to 1,100 lines of code. So here's web client now, but we can clearly see that there's some room for improvement. So for instance, what do I know about web client? Well, web client, our goal with it is to try to keep it only working, sort of that link between the browser. As we look ahead to introducing new functionalities, new frameworks like Playwright and so on, we'll rethink how this will work. But for now, the goal is to simply take away anything that would be specific to an element, right? Any of these objects, and put them into their own domain, right? They need to be responsible for what they do and nothing else. So what do I see here? I see things in web client that reference lookup. Well, I know lookup is here. So this, if I just by hovering over lookup, I can see, 1, 2, 3, 4, 5, 6, 7, 8 different, 9, 10 different, and it goes on, multi-value as well. All of these are potential improvements they can have that can be further refactored. So I would look at, okay, why is lookup item specifically in web client? Maybe it's being used by multiple ones, and how can we fix this, right? So if I were to move this one into lookup, just move it here, for instance, you'll see there's some lookup is using it, look, this one's using it, so on. So we'd have to kind of fix through that, but that's some further improvements that could happen that can further reduce the web client and make it more specific to what it needs to be. Thank you. Okay, so I thought this was interesting enough to record. So I actually started removing the lookup from web client. You can see we're actually down now to less than 1,000 lines of code. So definitely making some good progress. But when I started moving those out, and everything was, had to clean up lookup, and we got lookup nice and clean. But what's interesting is, look, it actually exposed further dependencies on lookup. So dialogues, entities, quick creates, timelines, business process flow. Saying, hey, I reference lookup, but I can't find it anymore in web client. Going back to what we talked about, we can't change the signature. But now we know that we have to have it, we have to reference lookup. So this should help overall with our code. So we'll do this here. Declare lookup. Now lookup set value. So I can actually take something like this and go to different places that would reference lookup. See, set header lookup, web client, try to remove lookup. We're actually going to do this and change this up a little bit here. We should see some changes here. Now again, we're refactoring this. There's maybe some things that have to change, but let's see right here. Remember, it cannot be set here. Try remove lookup value. So what is this? This is a static. I don't necessarily need that to be static per se. And that's changed, right? So that's a good one. So we can go through and continue to see. It actually helps us see where lookup is. It's a nice side effect of the refactoring that we're doing. So I just wanted to point that out in the recording. Okay, so by the end of this one, you should have a good understanding of why refactoring is important to code quality, why code quality is important. We've given you some basic examples on how to get started, right? Looking at maintainability, how to make code reusable, how to make it readable. These are all things that are going to be beneficial to your organization. There's never a bad time to start the refactoring efforts. There's never a bad time to start looking at your code, ensuring that it is meeting quality attributes. If you do get stuck on anything or you want to talk about this more, I've got my contact information here. Please do not hesitate to reach out. I look forward to hearing your progress on refactoring and code quality in general. Thank you and have a great day.